In this lesson, we're going to be talking more about polynomials, but now we're going to move to multiplying and factoring them. And remember, factoring is just like division. Example 1 asks you to multiply a monomial to another polynomial. In this case, it happens to be a trinomial. So you have one term being multiplied to what's in parentheses, which has 3 terms. Notice there's no addition or subtraction sign between these. If there had been an addition or subtraction sign, then you would have to follow the rules from lesson 8.1. If it was addition, you would just combine like terms, and if it was subtraction, you would distribute the negative and then combine like terms. But because we have multiplication, we're allowed to combine things that aren't alike and make them into one term. This is chapter 7, so hopefully you'll remember how to do that as we go through it. Go ahead and write this down, hit play when you're ready. It's just talking about the fact that we're going to distribute this monomial to every term in the polynomial. And in this case, our exponents are going to change because we're multiplying, we're not adding. When we add, we only combine like terms and we don't change those like terms. But when we're multiplying, we can combine any set of variables and numbers, put them all together into one term, and it follows the rules of exponents when we have like bases, because notice you have 2 y's there. So when you go to multiply this out, you're looking at each negative 4y squared times each term here. So I'm going to go ahead and just kind of write it the long way right now so you see each part. But typically you could draw an arrow, and as you get really good at this, you can just start doing this part mentally. But for now, we have negative 4y squared times 5y to the 4th is going to be one set. Then we're going to have negative 4y squared times negative 3y squared is going to be our second term. And then negative 4y squared times a 2 is going to be our third term. And we'll end up combining these at the end. So we have a negative 4 times 5. Remember, monomial times a monomial. All you're going to do is multiply the numbers and then add up like exponents. So negative 4 times 5 is a negative 20. And then we have a like base, y squared and y to the 4th, so we have a total of y to the 6th. So that's going to be your first term. Now you have a negative 4 times a negative 3, which is a positive 12. And then you have like bases again, so y squared and y squared gives you 4 of them total. Here, negative 4 times 2 is a negative 8. No like bases, so you just bring the 1 over that you've got. Oops, I'm so sorry. I said y to the 4th and then I wrote y squared. Sorry about that. Okay, there you go. So now you go to write this, and that's a good example of catching mistakes because I saw squared and knew I wrote something wrong. Rewrite it, negative 20y to the 6th, positive 12y to the 4th, negative 8y to the 2nd. This is your final simplified answer because you are now adding or subtracting terms and you don't have any like terms you can combine here. So that is your answer. If we were looking at naming this, it's a trinomial, 3 terms, and it's to the 6th degree. There's another way to look at this that I'm going to show you today because if you see it this way and you understand how it works, you don't have to use this yet, but tomorrow when we go over the next lesson, it's going to really help some of you out a lot. So I want you to see it in every form. This is the only time that it isn't as important, though, just so you're aware. It's using a rectangle, and it's based on that diamond rectangle problem set that you were doing. And what you're going to do is you have a monomial. So let's say we have negative 4y squared here. And then you have 3 terms. You're multiplying it to 3 terms. So you would set up, since you only have a monomial here, you'd only have 1 row, but then you would have 3 columns. because you're going to be multiplying it to 3 terms. And then you would put those 3 terms up at the top here. So we have 5y to the 4th, and then we have a negative 3y squared, and then we have a positive 2. And now this just kind of helps you to make sure that you distribute to each term. It's the exact same idea as what we had here, but you've got this rectangle to kind of help you make sure everything is distributed to. And again, when you have a monomial that's multiplying to some type of polynomial, this isn't as important, but starting on our next lesson, you're going to be multiplying more than one term here to more than one term here. And that's where it becomes really important to be able to see that. So again, if we were just to go through this, negative 4 times 5 would be a negative 20, and then we have 6 y's, so y to the 6th. Negative times the negative would be a positive, 3 times 4 is 12, and we have y to the 4th. And then negative 4 times 2 is a negative 8, and we just have a y squared. There's your 3 terms at the end. Negative 20y to the 6th plus 12y to the 4th minus 8y squared. You can use either or. You can either show me this step and show me all the pieces, or you can show me the rectangle for this lesson. It's whatever's easiest for you. And then as you get better, you can always go to what we're used to with distributing like that. But you just have to be so careful right now because of all the different stuff going on. And some of these are going to be a lot more complicated than the examples. Write these problems down. Try them on your own, and when you're ready to go through them, hit play. You can use either or when you multiply these out. There's one more, so you should have 5 problems done when you hit play again. I'm going to go ahead and show just one answer each time, one way of finding the solution. So whichever way you chose to use is fine, as long as you end up with the right expressions at the end. Okay, so I'm going to just go with distributing the first time. So I'm distributing 4b times 5b squared, so I have 4 times 5, which is 20. And then I have a b and 2 b's, so b cubed. Remember, that's a first power. Plus, because I have a positive and a positive, 4 times 1 is 4. And then I have a b and a b, so that is b squared. And then 4 times 2 is a positive 8 with the 1b there. This one I'm going to go ahead and use the rectangle, just so you can see the 2 ways again. So negative 7h. I'm multiplying it to 3 terms, so I should have 3 columns here and 1 row because it's 1 term. I have a 3h squared x. I have a negative 8hy and a negative 1. And then I just multiply each of them in. So negative 7 times 3 is a negative 21. I have 3 h's and 1 x, because remember, you can just combine those. Negative times a negative is going to be a positive right there, so be really careful with that. Now you have a positive 56, and you have h and h, so h squared and a y. And then again, be really careful. Negative times a negative is a positive. 7 times 1 is 7, so positive 7, and then you just have an h. So your final solution should be written as, I didn't leave much room, I'm going to write under here, negative 21 h cubed x plus 56 h squared y plus 7h. Next one, I'm just going to go ahead and use distributing. I'll actually do it the way that I showed you in the first example where we write each of them. So it's going to be 2x times x squared is going to be your first term. And then 2x times negative 6 is going to be your second. and then 2x times positive 5 is going to be your last one. So you end up with 2 times 1, which is 2, and you have 3 x's altogether. 2 times the negative 6 is a negative 12, and you have 2 x's. 2 times 5 is 10, and you have 1x. And then you would write that as 2x to the third minus 12x squared plus 10x. Cubic trinomial. This one, you would have actually had the fourth power if you were looking at that. All right, the last two, I was hoping to just catch some of you about what I talked about yesterday and just make sure you're really aware of that. I actually threw an addition sign in the middle here. So now what you're looking at is not distributing. You're looking at positive here is not going to change any of these. So all I'm going to do is put it in standard form and look for like terms. And notice I have a 2x and a negative 6x. X squared can come down. 2 minus 6 is a negative 4x. And then plus 5 can come down. And that should have been your trinomial right there. This is a quadratic trinomial. And the last one, same idea, except now we have a negative to deal with. So you would need to rewrite it first. 2x, distribute your negative to each term. Negative x squared, a positive 6x, and a negative 5. And then you would combine your like terms. And you end up with a negative x squared plus 8x, subtracting 5. So the rule that tends to cause the most trouble here is when you're multiplying, you need to remember to add up those exponents. And when you're adding and subtracting, you need to remember to only combine like terms and not change the exponents. That can get very confusing. You have to make sure you're really good at that. Now we're going to look at factoring a monomial from a polynomial. Again, it's the opposite of the multiplication. At the very end, I'll go show you what I mean by that. So write this on the left and then hit play when you're ready to go over the example. When you go to find the common factor of these terms, you're going to look for the greatest common factor of your coefficients, which are your numbers. And then you're going to look at each variable and you're going to determine how many they have in common. And those will be the things you pull out to factor. Let's try it with this one. First, I'm just going to look at my coefficients, at my numbers. So I have the numbers 4, 12, and negative 8. I need to find the GCF of 4, 12, and negative 8. And that's the greatest common factor. We're not looking at multiples, we're looking at factors. Number that goes into 4, 12, and 8. And it would be 4. So your greatest common factor is 4. Now you're going to look at the variables. There's an x cubed, there's an x squared, and there's an x. Common mistake, people want to say, oh, it's the one with the highest amount, but do they all have 3 x's in common? They don't. This one has 3 x's, this one has 2, this one only has 1. So if I'm talking about division, I can only take 1 x out of each. I can't take 2 x's from here because there aren't 2 x's to take. Can't take 3 because there aren't 3. But there is 1 that can be taken from each of those terms. So I can take 1x, which means my factor is 4x. When it asks you just to find the factor, that's all you're going to do. Our next step is actually going to be to pull out that common factor and factor this polynomial. But when it asks you just to find the factor, that is your stopping right there. Write these 3 down, try them on your own, hit play when you're ready to check them. So when you go through these, you looked at the numbers first, the greatest common factor of the numbers 5 and 10 was 5. And then when you look at the variables, there's only a v, and you're looking at how many they have in common. You can pull 3 out of here, and you can pull 3 out of here. So it would be v to the third. It's always going to be your lowest exponent. But you have to think about it that way because typically people want to pull out the highest exponent. But think about, I can pull 3 from here and 3 from here. Can't pull 5 from both. So your factor is 5v to the third. This one, if I'm looking at my numbers, the greatest common factor between 3 and 18 was 3. Variables, nothing. It's not applicable, okay? There's nothing there. So my greatest common factor of these two terms is just 3. You don't have to pull out any variable if there wasn't something in common. And then the last one, we're looking at the numbers. The first number that goes into 4, into -2, and into -6 would be 2. The reason I'm including the negatives is because what you're going to find is a lot of the time if all 3 terms or however many terms they gave you are negative, they want you to pull the negative out with it. But since only 2 of them were, you can leave it as a 2. And then if we're looking at our variables, we only have a b to look at. Sometimes you're going to have more than one variable. I have one b that I can pull out of each term. So it's just a b. So my factor is 2b. And that's a b, not a 6. If you got those right, then you're good to move on. If you didn't, you might want to go review the notes one more time. This is the last thing we're going to talk about in this lesson. Now we're going to apply what we just learned about pulling out a factor, and we're actually going to factor this, which was the goal in the end. When you go to factor a monomial out from a polynomial, so remember a monomial would be one term, you have to look to see if there is a common factor. If there isn't a common factor, you can't do this. But if there is, then you can factor these polynomials. You're going to find the greatest common factor of the polynomial like we were just doing. Then you're going to divide each term by it, and I'll show you how we're going to do that. And then you end up rewriting the same exact sum as a product right here by pulling out the factor, writing it on the outside, and then multiplying it to what's left on the inside. And I'm going to show you how that relates to that rectangle that you learned about with multiplying. Write this down, hit play when you're ready to go through it. So when you see this, the first thing you want to do is you want to find the factor. And you're going to do exactly what we were just doing. So I'm going to look at my numbers, and you might be getting this well enough now to where you don't have to do the steps. If I just look at my numbers, I have 3, I have -12, and I have 15. The greatest common factor between 3, -12, and 15 is 3. And then when I look at my variables, I have an x squared, and I have an x to the third power. I can pull one x out of each. So my greatest common factor there is 3x. Now, this is the part that can get confusing, so I want you to really pay attention to how you're going to write this. What you're going to do is you're going to take 3x squared, and you're going to divide that by the 3x. You're going to take the -12x, 3x cubed, divide that by the 3x. You're going to take the -12x squared and divide that by 3x. And you're going to take 15x and divide that by 3x. Now, this is applying Chapter 7's rules. Remember I said Chapter 7 is extremely important here. So you're going to use the rules that you learned in Chapter 7, and you're going to simplify each of these to get what's going to go inside parentheses. So 3 divided by 3 becomes a 1. I have an x cubed and an x, so this becomes just a 1x squared. Remember the rule, 3 minus 1 is 2, or you can think of canceling 1, I have 2 left. Okay, this right here is going to become a negative 4. 3 goes into 3 once, 3 goes into 12 4 times. I have 1x that's going to cancel in the bottom, 1 in the top, so 1 left over in the top. Be careful with that. If there for some reason ended up being 1 in the bottom, then you probably did something wrong, because they should all end up in your numerator. Now same thing, 3 goes into 3 once, 3 goes into 15 5 times, so I have a 5, and then my x's just become a 1, so I don't have any x's left over. Now I rewrite that with my factor on the outside, and then a set of parentheses and these 3 terms inside. X squared minus 4x plus 5. How this relates to that rectangle that we've been doing, or just distributing. Remember, multiplication and division are exact opposites, and factoring is like division. The way that I can check my answer here, if I distribute this 3x to these 3 terms, I should be able to get my original polynomial up there. If I don't get the original polynomial when I distribute that, I know I made a mistake. You should never miss these, because you should always be distributing it to check them. Don't distribute it and give me this as your final answer. This is your answer, but you check it by distributing it. 3x times x squared is 3x cubed. There's my 3x cubed. 3x times a negative 4x is a negative 12, and I have 2 x's, x squared. Negative 12x squared. 3x times 5 is 15x. There's my 15x. If I can't multiply this into here and get exactly that, I know I made a mistake, and I go back and I check my factor and I check my division here. I'm going to have you try a few now. Try these 4. I want them to be fully factored like this. Once you're ready to check them, hit play and check your work. First one, you're looking for your greatest common factor, and your greatest common factor of 8 and negative 12 is 4, and there's 1 x in common. Then you take 8x squared and you divide that by 4x, and you take negative 12x and you divide that by 4x. Here you end up with a 1 and a 2, x cancels, and you have 1 x left over. So you end up with 2x. Here, 4 cancels, negative 12 becomes a negative 3, x's cancel and become a 1. So this just becomes negative 3. Rewrite it, greatest common factor on the outside of the parentheses, terms that are left over on the inside. There's your answer, and you can check it by distributing, and 4 times 2 is 8, x times x is x squared, 4 times a negative 3 is a negative 12x. Second one, greatest common factor first. Greatest common factor between 5, 10, and 30 is 5. There's no variable in common, so 5 is your greatest common factor. 5 goes to the outside of the parentheses. This one isn't as hard, so this one you probably don't even, you can just divide it in. 5 goes into 5 once, and you have a d cubed left over. 5 goes into 10 twice, and a d left over. 5 goes into 30 6 times. Now check it. 5 times d cubed is 5d cubed. 5 times 2d is a positive 10d. 5 times 6 is a positive 30. Number 3. First I'm looking for my greatest common factor. Looking through my numbers, 6, 12, and 24. My greatest common factor is 6. If they didn't have a greatest common factor, it would just be 1. Then I'm looking at my variables. I have m squared, and m cubed. So they each have one m in common. I'm not going to worry about this n because there isn't an n in the other terms, so I can't pull any common factor of n out. That's my greatest common factor. Now I'm going to simplify each term by dividing it by 6m. So I have 6m cubed divided by 6m. I have a negative 12m squared n divided by 6m. And I have a negative 24m divided by 6m. And when I go through and simplify that, my 6's become a 1. And then I have m cubed over m, so I have m squared left over. My 6 becomes a 1, my 12 becomes a negative 2. 1m cancels, 1 stays. I end up with a negative 2mn left over. 6 cancels, and negative 24 becomes a negative 4, and my m's become a 1, and I have negative 4. Greatest common factor goes on the outside. What's left goes on the inside. And now I distribute it to check it, or I put it in the rectangle. 6m times m squared is 6m cubed. 6 times a negative 2 is a negative 12, and then I have an m and an m, which would be m squared, and an n. 6 times a negative 4, negative 24, and my m. Last one. Really easy to make a common mistake here, so pay close attention and make sure you did this right. If you didn't, make sure you kind of make a note about that. Greatest common factor with my numbers is 3, and I have one x in common. Now I simplify each term. I have 3x squared divided by 3x, and then I have 3x divided by 3x. My 3's cancel. I have one x left over there. These cancel, become a 1, and these cancel and become a 1. Now what happens a lot of the time is people just think, oh, that went away. It didn't go away, it canceled to become a 1. And you have to have that 1, and I'll show you why when we check it. So now you rewrite it, 3x times x plus 1. Remember, we've been checking these. This is one of the reasons we check these. If you had just made that go away, and you just brought an x down, 3x times x is 3x squared. But you wouldn't have a way to get to the plus 3x. The only way you're going to be able to get to plus 3x is 3x times x is 3x squared, 3x times 1 is 3x. You have to have those 1's there.